Hey guys, welcome back. In today's video, we're going to be performing an activity on linear versus logistic. Yes, so what we're going to do in this activity is basically we're going to check out the students' performance in their writing score. Last time when we were doing the actual activity, means the first activity, we were checking out their math score. But in this one, we're going to be checking out their writing score. So let's get started. First of all, we'll be importing the pandas as PD and making the computer reading the dataset. Why do we need to make the computer read the dataset? Why do we need this code? Because, well, if we don't have our dataset, we can't code on it. We can't work on it. But it's not always necessary to use our dataset. You can make dictionaries which doesn't require the dataset, and you lists which also doesn't require dataset. But since we're doing the advanced coding, we need a dataset. So that's why we will be needing the pandas library to read a dataset. Yeah, then we will be performing the EDA. What is EDA? EDA is the exploratory data analysis, which means the data inspection. Why do we need to use it? Well, we need to use it so we can, check out the information of our dataset. We're going to print the top 5 rows, the information of every column, and the type the type of data it is. Now we're going to import the label encoding. So from sklearn, we're going to import the pre-processing. This library is required because in this library stores label encoding. We're going to create a variable which is going to be encoder, which is equal to label encoder. We're going to convert gender, race and ethnicity, parental level of education, lunch, and test preparation course into numerical data. So from textual data, we're converting it into numerical data. This is, converting the textual data into the numerical data is important because the computer doesn't understand our human language that we're talking right now. It only understands zeros and ones, means binary numbers. So that's why it is important to convert it. And this will be our new data set with binary. Now we're going to store we're going to store some variables in X. So gender, race and ethnicity, parental level of education, lunch and test preparation course will be the independent variables, while writing score will be the dependent one. Why we need to store them? The computer can differentiate between them. So it can learn that this is the writing score, this is the independent variable. So all of this is independent while writing score depends on them. So if it's a good lunch or a good test preparation course, then the writing score will also be good. If it's bad, then of course it will be bad too. Then we're going to import from sklearn model selection, we're going to import the train test split. In train test split, the model splits the training data and the testing data. X train, X test, Y train, and Y test is all going to be equal to train test split. So we know that it's the values, it's the variables of it. We're going to do in brackets xy, and the test size is going to be 0.20. So means we have 80% of training data and 20% of testing data. Now we're going to go ahead and predict it with the linear model, means linear regression. We're going to import from sklearn linear model, we're going to import the linear regression. So linreg is going to be equal to linear regression, and now we're commanding it to fit xtrain and ytrain so we can predict it better. Otherwise it won't be well. So it listens to our command and does it. Then we're moving on to the next line, which is going to be a new variable, yprep. In this line, we are going to predict the values. Why do we need this? Well, basically, we're predicting. We need to know the results between the actual and the predicted one. So here we're going to create a data frame. D is equal to PD dot data frame. Now D, we're going to add, the actual and the predicted. So actual is going to be equal to y test, while predicted is going to be equal to y pred. Because y pred means predicted, so it's going to say predicted, and y test means the actual values. So it's going to be the actual. Now we're going to calculate the root mean square error. How do we do that? Yes, first of all, we import from sklearn, import the metrics. Metrics also contains accuracy score. Now from import numpy as np. It's the numpy library. So we're going to import the sklearn from import metrics and import numpy as np. So the root mean square error, like over here, now we're going to give a column and a, you know, what do we say, comma. Then we are going to do the syntax, and whatever the answer is, it will come over here. So np means numpy.sqrt means the root means square error. No, actually the squared root. So we're going to do the syntax, which is going to be np.sqrt metrics.mean and underscore square error y test and y pred. So we're going to be checking out the root mean square error of y test and y pred. Why is this important? Well, basically, this is important because we want to know what the root mean square error is. Have we done anything wrong? Is it good or bad? Have we trained the model nice? This is why. And our answer will be 11. The root mean square error is 11. Now we're going to create a new, column. So is writing past. So we're going to create a new column. So is writing pass equal to dataset dot get writing score. So this is our syntax of making a new column. And in this line, we're going to say that criteria mark should be above 50. Lower than that, then you're failed. So, and now we're going to, rename the column. So writing score to is writing fast. Then we're going to do the label encoding of is writing fast because it's probably, a textual data. Computer will not understand it, so we will need to convert it into the numerical data. So now we're going to, convert it into the numerical data. Over here too, we're going to fit in transform dataset is writing fast. Now we're going to choose the independent variable. So while, now the dependent variable is changed from writing score to is writing path. Now we're going to again import the library from sklearn model selection, import the train test split. So you are gonna divide the data into training and testing. So we're gonna do the same thing over here and the same test size. Now we're going to import the model. So we're going to say from sklearn.linear model import logistic regression. That is a syntax, a method to import logistic regression. So logreg is going to be equal to logistic regression. So my max iter is equal to 500. Now what is max iter? It means maximum iteration. And iteration means repetition. So maximum repetition is going to be 500. Now we're going to predict just like we did with linear regression. So ypred we're going to and then we're going to use logistic regression to predict x test. We're going to do the same thing to create a data frame. A data frame, to store the values. So actual is going to be equal to y test, y predicted is will be y pred. Then we're going to print the data frame. And yeah, now we're going to check the accuracy. And you must be wondering, why aren't we calculating, instead of the accuracy, why aren't we calculating the root mean square error? Well, basically, root mean square error consists of numbers, and it suits with linear regression more than logistic, because logistic is a categorical type of, categorical type of model. It is a family of the linear, but not fully like it. It doesn't have a straight line. It has a sigmoid function. Instead of multiple outputs, it has only two outputs, like gender male, female. It can be spam or not, yes, no, and many more that are only two outputs. So that's why we are checking the accuracy instead of the root mean squared error. Again, we're going to import from sklearn, import the metrics. Then we're going to print the metrics, metrics.accuracy score y test and y prep. So our accuracy score is 5. Now, the actual over here is 50 and the predicted was 52. Like 52 and 52. Over here, the actual was 52 while the predicted was 53. And same goes on with the list. You can see that there are huge difference. One difference, two difference, five difference. So just like that, linear and logistic are different. You might think they are the same from the same family, they should be the same, but it's not really true. So thank you so much for watching this guide. I hope you all understood what I was saying. If you had any queries regarding this, do tell me in the comments and I will try to resolve it. So I'll see you next time. Bye guys.